Hi, my name is Sanjana, and these are some of the equipment that I've used in my Stony Brook laboratory. After the safety lab, we did the research lab where we looked at real databases on the internet, such as this one for testing metals. We also looked at the USPT database to search for our professor's patents, such as this one. In the next experiment, we measured engineering components using handheld tools, such as a multimeter to measure resistance, and calipers for different sizes. We used lasers to measure diffraction and simulated crystals. Then we analyzed data from a real diffractometer to measure real crystals. We used a polariscope to visualize and measure stress. This is the stress pattern of a beam with a hole under 3-point bending. In the next experiment, we used a metallurgical microscope to measure the size and shape of small materials. Here we have a memory chip, calibration target, a TM grid, thermal place plots, cotton fibers, nylon, crystals, copper metal powder, pigmented plastic, wire mesh, and circuit board. We use computer software to measure the size of things like these simulated grains or crystals. We use the line technique here to count the number of grains, so like 1, 2, 3, 4, 5. We also use the average area technique to measure the average area of these grains. And on your right side, you can see the average areas, or the computer could do it automatically. And you can see the average areas displayed here. And we constructed truss bridges, like this one, and tested 360 pounds of heavy steel blocks. For the thermal experiment, we measured temperature of solid objects in many ways. We used dozens of infrared thermometers and cameras, like these. We also used an oscilloscope, a frequency counter, signal generator, USB scope, function generator, and much, much more. Here is a sine wave, a square wave, a triangle wave, and here are different frequencies of the triangle wave. We also measured the pressure and flow of liquids, gases, air, and vacuum. We measured the density of many liquids with hydrometers, and the viscosity with a digital viscometer and manual viscometers. We even used an electron microscope to see very small materials and determine their elements. These are gold crystals on a copper grid with an aluminum background. Next year, I'll measure hardness and micro-hardness, roughness and nano-roughness, magnetism, magnetic properties, the Hall effect, magneto-optic domains, superconductivity, and more X-ray diffraction and more electron microscope, contact angles, and much, much more. Welcome to Stony Brook, and I look forward to meeting you.